All right, so hopefully you said you're okay with the graph. So I'll do a really bad one, sorry. So you've got your circle and we know it's radius 2, so those are all 2's. And then we've got this line that goes through here, and we know that's root 2 and that's root 2. Okay, so we have that because we had both x squared plus y squared equals 4, and we had y equals negative x plus root 2. So we know that. And then the area we're interested in is finding that area. So if we have a look at what we've got, we know that this, if I draw a line like this, we know that this line here, y equals x. Remember, this line here is y equals negative x plus root 2, but the gradient here is negative 1, the gradient here of positive 1. So they are at 90 degrees to each other. And we are interested in this, basically we're interested in this whole angle here, but we can figure that out by just finding that little angle there, half of that angle. Because if we've got that whole angle, so this whole angle, we know the formula for area is half r squared theta, take away half r squared sine theta, because half r squared theta is the area of the sector, right, the sector, and then we're subtracting this bit, which is the area of the triangle, half AB sine C. Right, so once you find theta, we're all good because we know the radius of this circle is 2. So it's all about just finding that angle. So what you've got there is, remember the question said, we had this one, we had z minus 2 cis pi on 4. So 2 cis pi on 4 being out here, and it says basically the distance from 0 to z, so 0 to any point z, is the same distance as that z, the distance from z between z and that point 2 cis pi on 4. So 2 cis pi on 4 is out here because it's at an angle of pi on 4, which is a gradient of 1, and it's got a length of 2, so we're out there. So then, and z being here, right? So the distance from 0 to z, so that distance there, we can't see, is equal to the distance from here to here. So these are equal. And we know that distance is just the radius, which is 2. So now we've got that blue bit there being 1 because it's half of it. And we also know that red line here is 2 because it's also the radius, the radius of a circle. And we know, I'll just put, that was supposed to be yellow, that yellow in there. And we know that's 90 degrees there. So we can use that to find this little angle here using, let's say, cos. Can't always hide, so half. So we know that cos of pi of 60, which is pi on 3, is a half. So now if we want that whole angle, we're just going to double that. So what we're putting in for this angle here is 2 pi's on 3. Now, I see in their solution they put sine pi on 3 for this bit, but it's exactly the same because remember in the first quadrant and the second quadrant sine theta is positive. So it doesn't matter if I put in 2 pi on 3 or pi on 3, it'll be the same because we're sining it. All right, I hope that helps. Let me know if it